Hey, we've made it this far. We might as well keep going. Chapter 12, Lesson 8 on inequalities. Inequalities. Now, one of my most famous sayings through my classes is that life isn't fair, but math is. But even within math, all right, even within the most fair and equal subject out of all of them, there are things that exist that are called inequalities. An inequality is a mathematical sentence stating that two expressions are not always equal. All right, so here's an example of one. Here's an example of an inequality. Ready for it? 3 is less than 5. This is an example of an inequality because this is actually true that 3 is less than 5. $3 is less than $5. But all an inequality is saying is that these two statements are not equal. Okay? There's a lot of other inequality symbols. So here, why don't we go ahead and take note of these. We have 5 inequality symbols. The first one is less than. Now remember, we read math from left to right, so if you get confused, I remember when I was a young lad going through the trials that you're going through in math, I would always get these confused, but then I realized that we read math from left to right, and if I put any number, like let's say 5 is less than 6, I would read this from left to right. 5 is less than 6. And this is true because I talked about the idea of baby bird's mouth. Baby bird would rather have 6 worms than 5 worms. 5 is less than 6. You could also use this symbol is greater than by flipping it, making the other way around. 3 is greater than 2. Baby bird would rather have 3 worms than 2 worms. And this would be left to right. 3 is greater than 2. Then we have 2 special symbols that have the option to be equal to. So this is just like the less than symbol, but it has the option to be equal to. And whenever you see the words at most, this is really important because this is going to show up not only on the homework, but on the quiz or test as well. Whenever you see the words at most, it means less than or equal to. Here's an example. 5 is less than or equal to 10. Okay, this is true. Right? In the same way, I can say that 10 is less than or equal to 10. Because even though it's not less than, it has the option to be equal to. And the same rule applies for greater than or equal to. If you ever have a line underneath it, it means it has the option to be equal to. And if you ever see the words at least, all right, it means greater than or equal to. Now here's an example. If I said you need to score at least an 85% on the test to keep your B in the class, you can score greater than 85 and still keep a B, but you can't score less than. So this is an example of greater than or equal to at least. And the last one, the fifth one, is the sign not equal to. It has the equal sign with a slash through it, which means it is not equal to. All right, example number 1. Write an inequality for each sentence. And just like writing an equation, the first thing I want to do is I want to figure out, well, which inequality am I using? It says the sum of n and 9 is at least 12. So, is at least is the indicator for us of which inequality is supposed to be. Is at least. If you go back and you look at our list, at least was greater than or equal to. So I'm going to go ahead and put greater than or equal to right there. All right. The sum of n and 9, so sum is addition, so this is going to be n plus 9 is greater than or equal to 12. Make sense? All right. The next one says a number less than 3 is less than 5. Now, this one has 2 different less thans. How do I know where the inequality is supposed to go? Well, just like we look for the word is in equations, we're looking for the word is to kind of start our inequality. Is less than. less than looks like this. And it says a number less than 3 should be 3 minus n. All right, remember, whenever you have the term less than, it's supposed to go in the back. So this is 3 minus n is less than 5. All right, so some of these can be a little tricky, but we want to be careful with them. Let's go ahead and practice this a little bit more. It says the product of 5 and h is not equal to, so that symbol looks like this, and does not equal to 7. So the product of 5 and h is just 5 times h does not equal to 7. And that would be our inequality. The sum of 5 and the quotient of 3 and x is at most 2. So is at most is actually less than or equal to. A lot of people confuse this. They think most is more than, so it's greater than, but it's actually going to be less than or equal to. We can go back and look at our list and say that is at most is less than or equal to. And we know it's at most 2. So that's the right side. The sum of 5 and the quotient of 3 and x. So this would be 5 plus the quotient of 3 and x. Quotient is division. We write it as a fraction. And this would be our answer. The sum of 5 and the quotient of 3 and x is at most 2. Now, one thing that's true about all inequalities is they have more than one solution. So, for part of your homework, you're going to be checking to see, is the solution true? For which inequality is 15 a solution? So the only way that we can do this is if we plug this number in. We plug it in for our variable. So we would write this as 2 plus 5 times 15 should be less than 7. If this is true, it is a solution. All right, and then we ask, is it true? So 5 times 15 is the same thing as 75 plus 2. All right, and 2 plus 75 is 77. Is 77 less than 7? No. So it is not a solution. Okay. Now let's go ahead and try this next one. We want to go ahead and plug in 15 for x. So I have 3 times 15 minus 13 should be less than or equal to 6. 15 minus 13 is the same thing as 2. And 2 times 3 is 6. And is 6 less than or equal to 6? Well, yes, because it has an option to be equal to, so it is a solution. So this checks out. So we're going to be answering the question, is it true? Is it true? Okay, let's go ahead and try one of these just so we kind of get used to this. Let's just try one. They're asking if p is equal to negative 0.5. I plug it in. Is it true? So 4 plus 8 times negative 0.5 does not equal to 0. Is it true? Well, negative 0.5 is the same thing as negative 1/2. If I use a calculator, I will figure out that 8 times negative 0.5 is negative 4. 4 minus 4 is 0. Does 0 not equal to 0? No, it is not true. This is not a solution. Is the given value a solution to the inequality? I would say no, because it is not true. All right, cool. Let's change the color. Let's go to the next slide. Now, we're going to go ahead and talk about how to graph inequalities on a number line. Now, here is an example of an inequality. X, an algebraic inequality, x is greater than 3. Now, I would want to graph this on a number line like this. Whenever I have a number line, I would always want to have, and this is the way that I want you guys to draw this. This is a shortcut method, and it's a very valuable way and a very time-saving way. So your book might look a little different where they put the number, and it looks a little different. But how I want you to graph it, I would want you guys to always start with 0 in the middle. And because we're comparing it to 3, I need to figure out where would positive 3 be on a number line. Well, positive 3 goes to the right because it's on the positive side. Okay? Now, this sign, less than, is going to be an open circle. An open circle. See how this is an open circle? So an open circle would look like this. If it had the option to be equal to, it would be a closed circle where you just kind of fill it in. And we're going to use the arrowhead method to graph this. The arrowhead method says that if you have the variable on the left, in this case the variable is on the left, alright, we're going to have an open or closed circle based off of whether this has a line or not underneath it, and it's going to point in the same direction as the arrowhead. Notice that this thing is pointing to our right, and the arrowhead of our graph is pointing to the right. So let's go ahead and practice these. Pretend like we didn't see these. Let's get rid of these. Alright, let's practice graphing these. Okay. Let's go ahead and graph. So I'm going to start by drawing, that's a terrible line. I'm going to put 0 in the middle. I always put 0 in the middle. And positive 2 is going to go to the right. Now, you don't have to put all the tick marks in between. That's not super important to me. What I want to make sure is I ask, is this going to be an open or closed circle? Well, it's going to be an open circle because there's no line underneath it. And the arrowhead is going to point to the right because this guy points to the right and this guy points to the right. Now, what does this mean? This means that any number underneath our line is a solution. It means that any number that is greater than 2, 3, 4, 5, it makes the solution true. Let's go ahead and graph this one. Now the big difference between this one, we always start with 0 in the middle, is that we have the option to be equal to. So positive 2, closed circle, going to the right, because this arrowhead is pointing to the right. And this only works if the variable is on the left. All right. Let's go ahead and practice a few more. All right. Graph this guy. All right. So first off, we notice our variable is on the left, so that's a good news. Now, we're going to go ahead and put an open or closed circle. So a reminder, if you have these, it's open. And if you have the option to be equal to, it is closed. All right. So in this case, we're going to have a closed circle at positive 4, pointing to the right. This one, we're going to have an open circle at negative 3. Now notice I don't have to put all the tick marks. I'm just going to put an open circle. And this arrowhead is pointing to the left. Now this guy is kind of interesting because we know that this thing is not equal to 2. It's any number other than 2. So positive 2 is on the right, open circle, and it's going to point both ways. Why? Because any number underneath the number line, as long as it is not 2, is a solution. And the open circle means that it's not a solution at that point. Here, 4 is a solution because I can plug 4 in and I can get a true statement. But I can't plug in 3 right here because 3 is not less, or negative 3, because 3 is not less than negative 3. Alright, let's try these last 3 and then we are done with the lesson. Alright, so make a number line, put 0 in the middle. P is not equal to 0. So because it's not equal to, we're going to put an open circle, and it's going to go both ways. It's every number that is not 0. Alright, let's just do a different color. Alright, number line, 0 in the middle, positive 5, open circle pointing to the right because the arrowhead points to the right. Let's just do one last one for this one. We're going to have a number line, oh you can't even see that, 0 in the middle at negative 3, and it's going to be a closed circle. A closed circle, this is a terrible color choice. Alright, closed circle pointing to the left because the arrowhead points to the left. And that's how you graph inequalities, and that's your introductory lesson to algebraic inequalities. Hope you loved it, guys.